Hello, good evening.
Good evening, sir.
Yes, first tell me your doubt. Mamuna,
Yes, sir.
any doubt
No, sir.
from any chapter?
No, sir.
Saifullah, Matthew, any doubt?
No.
You all have solved assignment related to this part?
Sir, I had exams, so I couldn't do it.
Okay. Is it UT or final exam?
Sir, it's mocks, so
Okay. Just 1 minute. Saifullah, are you there? Let me define your first this assignment. Try to solve on your own this first question, in which we have a wave traveling towards positive x-axis, having displacement along y-axis, 1 meter as amplitude, 2 pi meter as wavelength, and 1 by pi as frequency. So amplitude we have 1 meter, wavelength. So you may find k, which is equals to 2 pi by lambda. Wavelength in this part we have 2 pi, so 2 pi will cancel out, so you'll get 1 radian per minute per meter. Omega is equals to 2 pi f, and f we have in this part is 1 by pi, so it will be 2 pi multiplied by 1 pi, that is 2 radian per second. Good, Mamuna. So according to the equation, y equals to a times sine kx minus omega t. Now, if you put k is equals to 1 and omega is equals to 2, amplitude we have 1, so you get sine x minus 2 times t. So this will be the equation related to this part. Matthew, which option will be correct related to this one? Is it option D?
Sir, D.
Good. Now, just in second question, we have a transverse wave is represented by y equals to a times sine omega t minus kx. For what value of wavelength? Wave velocity is equals to maximum particle velocity. In last class, I defined you wave velocity, which is equals to omega by k. And maximum particle velocity, it will be simply omega times a. So these two terms are equal to each other. So just equate them. So omega by k is equals to omega into a. Omega and omega can cancel out. You may write k as 2 pi by lambda. So it will be lambda divided by 2 pi equals to a. So lambda will be equals to 2 pi times a. Good, Mamuna. Matthew, Is it clear? So which option will be correct? It's option C.
C, yeah.
Good. Next question is a wave described by this. So this term will be amplitude. Coefficient of x will be k and coefficient of t will be omega. We have to calculate speed of wave, frequency, direction of propagation, and wavelength. So from this part, we have k is equals to 10 pi, which is also equals to 2 pi by lambda. So lambda will be equals to 1 by 5 meter or simply 0.2 meter. Now we have negative sign in between this term and with x. So we can say this wave is going towards positive x-axis. So we have positive x-axis B and C option. In which option we have lambda equals to 0.2 meter, both. So further we have to calculate frequency. Omega equals to 10 pi, just equate it to 2 pi f. So f will be equals to 5 hertz. Amuna, which option will be correct? A wave which is going towards positive x-axis.
C option number C.
Good. Matthew, is it clear?
So yeah, okay.
Question number 4. A transverse wave going along positive x-axis represented by this. So first term will be amplitude, k, omega, and phase difference. We have to calculate speed. K, we have okay. So we have k is equals to 0.5 pi and omega is equals to 4 pi. According to the formula, velocity is equals to omega by k. Omega we have 4 pi and k is 0.5 pi. Pi cancel out. So you'll get 4 divided by 0.5. Move this point, 10. 40 divided by 5, it will be 8 meter per second. Good, Mamona. Matthew, which option would be correct?
B, sir.
We have 8 meter per second.
Oh yeah, so
That
C,
is
yeah,
C.
sorry.
Okay, you may write. This is another assignment related to the last concept about standing wave or stationary wave and beats. First question is, we have two different waves having wavelength 5 meter and 5.5 meter respectively. Velocity of sound is 330 meter per second. We have to calculate number of beats per second, that is beats frequency. Mamana, how to calculate beats frequency? Beats frequency equals to simply difference of frequency of two waves. So if for this part, we have to first convert this wavelength into frequency. So according to the formula, velocity is equals to wavelength times frequency. So frequency will be velocity by wavelength. Velocity we have 330, wavelength 5. So you'll get 66 hertz for this part. Similarly, for F2, 330 divided by 5.5. So it will be about 60 hertz. Now we have to calculate beats frequency. So it will be difference of frequency of two waves. Just subtract these two parts, you'll get your answer. Good, Mamuna. Wahid, what would be the answer? First frequency we have 66 hertz. Second frequency we have 60 hertz. Good, Matthew. So on subtracting, you will get 6 hertz beats frequency. Saifullah, are you there?
Yes, sir.
Any doubt?
I didn't understand anything. I have to see previous classes videos also. I was absent
Okay.
for I guess 2 or 1 class.
Okay, no problem. In question second part, we have y equals to a times sine omega t. So this 500 pi will define you nothing but omega. And omega is equals to 2 pi f. So just equate it to 500 pi and you'll get f1. Similarly, for second part, omega 2, which is equals to 2 pi f2, 506 pi. Try to find f1 and f2 from these two parts, and we have to calculate beats per minute. It means calculate beats frequency and multiply it by 60 to convert it per minute. Try to solve. Calculate f1 and f2 and difference them. Just multiply them by 60, you'll get this answer. Two pi f equals to 500 pi, so f1 will be 250 hertz. 2 pi f2 is equals to 506 pi, so f2 will be 253 hertz. So beats frequency in this part will be difference of frequency of two wave, that is 3 hertz. It means 3 beats per second. We have to convert this particular part into per minute. So you may write 3 divided by 1 second is equals to 1 by 60 minute. So it will become 3 into 60, that is 180. Mamuna, is it clear?
Yes, sir.
So option B will be correct. Try to answer question number 3. We have to check most correct answer, Mamuna. Let me just show you. In this part, first wave is and second wave, both are starting from same point. So we can say these two waves are in same phase. And if amplitude of this part and amplitude of this part will be equal, so they will overlap on each other, producing maximum sound at loud point and minimum or zero sound at this faint point. That's why amplitude should be equal for these two waves. Mamuna, is it clear?
Yes, sir.
Now, which will be correct option now for question number 3?
Option A.
Different frequency, same amplitude and same phase. So it should be C option. Okay.
Okay.
Matthew, is it clear?
Yes, yes, I understood.
Now in question number 4, we have coefficient of T 10, coefficient of X, and this is constant term, which is initial phase. We have to calculate phase difference. Last class I defined you how to calculate phase difference. Delta phi equals to K times delta X, and delta phi is equals to omega times delta T. K is coefficient of X. In this part, we have 0.0080, and delta X, and this is 0.5 meter. Since K is in radian per centimeter, so you must have to convert this meter into centimeter. So multiply it by 0.5 into 100. You'll get phase difference for this part. Similarly, in second one, delta phi equals to omega. Omega we have 10, and time difference for this is 0.5 second. So it will be 5 radian. Mamuna, is it clear?
Yes, sir.
In last question, we have y is equals to this. Matthew, just tell me, is it traveling wave or stationary wave?
It's a stationary wave.
Good. We have to calculate frequency. So this part will define you omega. This part will define you K. And this part will be total amplitude. So total amplitude will be twice of individual. So A will be 3 centimeter. K we have 2 pi by 66, which is equals to 2 pi by lambda. So lambda will be 6 centimeter. Amplitude, wavelength, frequency. Omega is 160 pi. So it will be 2 pi f. So f will be 80 hertz. Now from this part, we have to define separation between two successive nodes. In last class in a stationary wave, we have calculated position of node and antinode. Let me just show you. This is node. So this will be one of the node. This will be other node. We have to calculate distance between two consecutive nodes. So just subtract these two parts, you will get lambda by 2. It means distance between any two consecutive nodes will be lambda by 2. Similarly, if you have to calculate for antinode, this will be first antinode and this will be second antinode. Difference of these two terms will be again lambda by 2. So from this we can say position of or node and antinode differ by lambda by 2, both. So using this concept, in this question we have to calculate, find separation between two successive nodes. So separation between successive node will be lambda by 2. Lambda we have 6 centimeter divided by 2, so it will be 3 centimeter. Matthew, is it clear?
Yes.
Last part, we have to write equation of progressive wave related to this part. So general equation will be y equals to a times sine omega t minus kx, in which we have a as 3 centimeter, sine omega is 160 pi t, and k is 2 pi by 6 x. So this will be a general equation of progressive wave related to this part. Mamuna, any doubt?
No, sir.
Now let me define you different question related to this chapter that will be expected to come. First question you will be asked from this part will be ratio of RMS velocity of gas and velocity of sound. In kinetic theory of gas, we had VRMS is equals to 3p by rho root under, and velocity of sound using Laplace correction was gamma times p by rho. So you'll be asked to take the ratio of these two terms. So just divide them. So VRMS divided by velocity of sound will be root under 3 by gamma. Saifullah, any doubt?
Sir, explain it again.
We have to simply calculate ratio of RMS velocity of gas, which we have learned in kinetic theory of gas, and next velocity of sound. So VRMS is root under 3p by rho, and velocity of sound according to Laplace correction is gamma times p by rho root under. We have to calculate a ratio of these two velocity. So just divide these two terms, you'll get this part.
Yes, sir.
Okay. Next question will be why transverse wave can travel through solids only, but longitudinal wave can travel through all medium. Maimuna, just tell me the answer related to this part. What is the reason behind it? Yes, Maimuna. Saifullah, could you explain why transverse wave can travel through solids only, but longitudinal wave can travel through all medium?
Sir,
Yes,
Sir, I think in transverse wave, it has a lot of area and it has also low densities in the mediums. So that's the reason it travels only in solid.
okay, and what about longitudinal wave?
I think longitudinal wave has lower area and has higher amount of density, and that's the reason it can travel in all the three mediums.
Just let me define you. Let me just show you. This is transverse wave, which is depending upon elasticity in shape. That is Young's modulus. And Young's modulus we can define only for solids. That's why transverse wave can travel through solids only. But longitudinal wave depends upon bulk modulus, that is beta, or you can say compressibility of medium, which may be defined for all medium. So I had written, since velocity of longitudinal wave depends upon beta, which is defined for all medium, hence it can travel through all medium. Is it clear?
Yes.
Next, we may define bulk modulus of solid will be greatest than liquid and then gas. That's why velocity of sound will be maximum through solids, then liquid, and then gas. So velocity of sound should be greatest in solid, then liquid, and minimum through gas. Saifullah, any doubt?
No, sir.
Next question related to this part will be, you'll be asked to define longitudinal wave, derive derive expression of velocity, define Newton's assumption, and Laplace correction to it. This entire question will be of 5 marks. So for this part, you have to answer from this, that is longitudinal wave, its definition, velocity, Newton's assumptions, and then Laplace correction to this part to get 331 meter per second. This entire thing you have to write. Mamuna, is it clear?
Yes.
Next, you will be given equation of traveling wave from which you will be asked to find 4-5 things: amplitude, frequency, wavelength, time period, direction of propagation, and so on. Similarly, you will be given equation of standing wave, and you may be asked from that equation these different things. And one more thing, you will be asked to define beats and calculate beats frequency, like what we are doing in the last part. So this is the entire thing about this particular chapter, waves. Any more doubt?
No, sir.
So which chapter do you want to revise? Oscillation, thermodynamics, thermal properties of matter?
So all chapters are finished.
Yes, in last class we have finished syllabus.
Okay.
So we can do oscillation.
Okay. In oscillation, there will be a question to define how you can distinguish any particular equation to be performing SHM or periodic, non-periodic, and so on. Let me define you by giving example. Any trigonometric function like sine, cos, tan, cosec, sec, if the expression will be in those different terms, so it will be periodic if having linear power. Suppose if you have y equals to sine omega t, sine 2 omega t, and so on. It will be SHM or periodic or both. Mamuna, any idea? You will say in this part, since we have sine function and sine function, so it will be periodic. But for SHM, this part and this part should be equal, which is not in this part. So we can say this is periodic, but not SHM. You may prove this particular part by differentiating it twice. For any different equation, suppose if you have y equals to log of omega t, and you have to define if this is SHM or not. So just differentiate it with respect to time. Differentiation of log will be 1 upon x, and further differentiating it will be omega times t1. So omega and omega will cancel out. So you'll get t raised to -1. Further differentiate it, you will get n x to the power n minus 1. That will be 1 over t squared. So this expression is not identical to the displacement part, that is y. So we can say this will not be SHM. And also it is not periodic. So it is non-periodic. Saifullah, any doubt?
No, sir.
Next question will be, you'll be given any equation related to SHM, like if we have y equals to 0.02 sine 120 pi t plus pi by 4. And you'll be asked different term related to this. Like we have to calculate, suppose amplitude, time period, frequency, initial phase, velocity of particle or velocity of body in SHM maximum, similarly acceleration maximum, and so on. Just 1 minute. Doubt in this question?
No, sir.
No, sir.
The next question will be on the basis of energy. You'll be given numerical related to mass equation on the basis of which you'll be asked to calculate potential energy, kinetic energy, and graph related to that part. So just revise those different equation and graph related to those problems. The last part of it will be calculation of time period, for which I had defined you a spring mass system in which we have done series combination, parallel combination, then simple harmonic motion, simple pendulum, oscillation of bob. Let me define you one more thing. There was topic undamped oscillation. And damped oscillation. If your school willing to ask some difficult question related to this oscillation, they will ask you this part, damped oscillation, or calculation related to this part. In this part, we had amplitude equals to A naught e raised to the power b over 2 times of m into t. And similarly, we may write energy is equals to E naught e raised to the power b over m times t. So from this part, you'll be asked to find time in which amplitude of body becomes 1/3, 1/4, 1/5, and so on with respect to its previous value. So how to calculate these type of problems? Let me define you on the basis of this as we have A is equals to A naught e to the power minus B by 2m into t. So move this A naught to left side. So you will get A over A naught e to the power B by 2m into t. Now in this exponential, we have negative sign. So if you reverse this particular A and A naught, it will become positive. So A naught over A will be E by 2m into t. Now taking log to both sides, so ln A naught divided by A will be equals to B by 2m into t. So time equals to 2m divided by B ln A naught by A. You'll get time to change its amplitude from some initial value to some final value. Similarly, in case of energy, it will be m divided by b ln E naught divided by E. Mamuna, any doubt?
No, sir.
Let me give you a question related to this part. A Bob having mass 200 gram and viscous medium having damping constant 40 gram per second. Find time in which it becomes half of initial. Let me define you how to solve. In this part, we have mass of Bob 200 gram and damping constant 40 gram per second. It means M is 200. You may write it as 0.2 kg. Damping constant B, which is 40 gram per second, you may write it as 0.04 kg per second. Now use the formula. We have to calculate time in which its amplitude becomes half of its initial value. So according to the formula, T will be equals to 2 times of M, that is 0.2, divided by B, which is 0.04, ln A naught by A. Final amplitude becomes half of its initial amplitude. It means A naught by 2. So A naught and A naught will cancel out. Now just simplify it. 2 into 2, it will become 0.4 divided by 0.04. So it will be 10 ln 2, and ln 2 is 0.7. So it will be 10 into 0.7, that is 7 seconds. So just remember these two different formula on the basis of which you will calculate these two different terms. Saifullah, any doubt?
So in the above equation, can you say what's E again?
Small e or capital E?
Both.
Small e is exponential function. I defined you in damped oscillation. If there is viscous medium, so it will tend to decrease the amplitude as well as energy exponentially to that particular bob. So your amplitude will be A is equals to A naught e raised to the power minus B by 2m into t. And in right hand side, I have just calculated energy related to that part. Is it clear?
Yes, sir.
You may write it.
Sir, please go up.
Okay.
Sir, can you go a little down?
Done.
One second. I'm done.
Saifullah, done.
No, sir, 1 minute.
Saifullah, done.
Yes, sir. Sir, can you say how A became A naught?
No. in the question itself, we have to find time for which amplitude becomes half of its initial. It means your final amplitude at any instant becomes half of its initial. That's why I put A is equals to A naught by 2. So A naught and naught will cancel out and you will get ln2.
Yes, sir.
Okay. Now there was a question. A spring balance has a scale that reads 0 to 50 kg. The length of a scale is 20 centimeter. Suppose a spring balance which can read 0 to 50 kg and it may elongate to 20 centimeter maximum. So from this, we may find spring constant related to this part as F equals to K times X. So it can measure up to 50 kg. It means total force we can apply on it will be 50 kg. So Kx will be equals to mg. So K will be m into g divided by x, which is 20 centimeter. 20 divided by 100. 0. 0 will cancel out. 5. So 5 into 5, 25 into 100. So it will become 2500 Newton per meter. Matthew, is it clear?
Yes, sir.
Now a block is attached to it, which can oscillate with time period 0.06 second. We have to calculate weight of that particular block. Let's say mass m is attached to it and its time period is 0.06 second. So according to the formula for a spring mass system, it will be 2 pi root under m by k. We have k, 2 pi and time period. Just rearrange it. So t square equals to 4 pi square m by k. We have to calculate mass. So m will be equals to k times t square divided by 4 pi square. K we have 2500. Time period is 0.06. So it will be 36 into 10 to the power minus 4 divided by 4 pi squared. You may write it as 10. Now just simplify it, you'll get your answer. So 4 into 9 times. 0 and 0 will cancel out. 25 into 9, it will be 225. And we have 10 and 30, so it will be kg. If you have to calculate weight of this particular block, just multiply it by gravity, you'll get weight of this particular object. Mamuna, is it clear?
Yes.
This was a question from your examination paper. Just write it down.
And sir, in k equals to mg by x, why did we multiply it by 100?
To convert centimeter into meter, we have x in centimeter.
Yes, sir.
Done.
Saifullah, done?
Yes, sir.
There was another question related to this chapter is, find total energy of particle executing simple harmonic motion and show that graphically the variation of potential energy, kinetic energy with time. I define you in SHM. This is potential energy. This is kinetic energy, expression of kinetic energy. If you add these two terms, you will get total energy. And graph related to this two energy will be this part. So you have to write answer from that to this part. So you'll be asked to derive these different results. Okay.
Okay.
So this is all about this entire SHM. You'll be asked only these different parts. And next, time period related to combination of spring, series and parallel and so on. So let's stop here for today. In next class, I will define you kinetic theory of gas, revision, and then thermodynamics. You may revise those two chapters. Okay, we'll continue next class.
Okay, sir.
Thank you, sir.
Okay, thank you.